We're trying to solve this integral by using this transformation, as crazy as that seems. But essentially, we're going to be looking at this map. We've already been given a couple of lines, and we're going to redraw this as in terms of u's and v's, so we can get these things. Now we really need to pay attention to these points. In order to find that intersection, we're going to set this line equal to this line, and we'll be able to say that negative x plus 1 equals 2x plus 2, and we can rearrange this by saying, negative 3x equals 1, and then we'll find that x equals negative 1/3 over here. Now, we'll notice it's right over here, negative 1/3. That point, I'll put it like right here, negative 1/3, comma, and we'll see it's going to be like 1 1/3. So it's going to be like 4/3 right there. We can actually eyeball these from now on. You can also do the calculations if you want, because this one is going to be like 1 1/3, a negative 1, that would be negative 4/3, and then it would also be 1 2 1/3, which is going to be 7/3. And then that's going to map out to a new point. This one here is going to be like negative 1/3, and then 1 2 3 4 1/3, which would be 13/3. So negative 1/3, 13/3. And then the next point is going to be 2/3, and then 1 2 3 1/3. So 2/3, and then that would be like 9 10/3 or so. Okay, so these are going to be the 4 points, and we'll remap these by plugging them into this equations. And we'll say, we're going to need a calculator here a little bit, because the first one is going to be like y plus x, which is going to be, adding those two together, we should get a 1 out of that. And then we'll get, here we'll get 2/3, and then plus the 4/3. So that would give us a 2 on that one. On this one, this would be, you see, negative 4/3 plus 7/3, which would give us a 1, and then we're going to do like 8/3, and then plus 7/3. So we get 5 here. On this one, we're going to be doing, like it's like 13/3 minus 1/3. Adding them together, we get the 4, and then over here is going to be like 2/3 plus 13/3, which gives us a 5. And on this one, it's going to be, again, the 2/3 plus 10/3. So we get 4, and then we'll get like 4/3 plus 10/3 for the final piece. Negative 4/3 plus 10/3. So we get 2. Now we can remap this. I'll just draw it like right here a little bit. We can see that. All right, so we got 1, 2, this means 1. I guess I'll draw it kind of small. So 1, and then 2. And then we got the 1, and then 1, 2, 3, 4, 5. And then we have 4, 1, 2, 3, 4. And then let's go 1, 2, 3, 4, 5. And a 4 and a 2. So we essentially have this little square here that we've mapped out onto. Not too bad. And we see that our points are going to be 4, 2 to 4, 5. And then this is going to be 1, 5, and 1, 2. So now we can look at our new integrations almost. Okay, we're close. So we have to make some use substitutions. I thought this was a strange substitution because we're making it more complicated essentially, but you'll see. We have to put this x here in terms of u's and v's. Otherwise, if we try to plug in this du dv situation, it's going to be a problem. And we haven't even figured out what the du dv Jacobian is. We're going to have to do that later. But let's start with this first. Let's rearrange this equation by putting y on this side, so we get u minus y. Then on this one, we see that the y would actually equal like v plus 2x. So that's what we're going to put in over here. So x equals u minus v plus 2x. We can rearrange this by essentially adding the 2x onto this side. So we get 3x equals u minus x, or u minus v, and then x equals u minus v divided by 3. So we figured out what x equals. That's what we can plug into there. So we'll say 4 u minus v over 3. Now the du dv situation, we'll do that over here, because we are going to take these equations, or not this one, it's this one. So we're going to take these two equations, and we're going to go du equals dy plus dx, and then dv equals negative 2 dx plus dy. And we can actually try to rearrange these two, switch them a little bit, just to make it a little bit easier to read, dx and dy on that side. Because then we could see how this will transform into a little matrix down here. Du dv is going to be equal to, we have a 1 and a 1 and a negative 2 and a 1. And then we'll put the dx and the dy. We could solve the little thing is going to be 1 plus 2, which just gives us 3. So in the end, we kind of see that du dv equals 3 dx dy. That is the Jacobian right there, 3. We'll divide the 3 on both sides, so we get du over dv equals dx dy, etc. We'll put that over here. Du dv divided by 3. Okay, great. So we'll pull these constants out. And we also have to add the limits, but we'll put that in a second. So 4/9, and here we go. And then we'll have basically u minus v. This is the integral, du and dv. This is actually really easy. And now if we want to look over here to see where the u's and the v's go on the uv plane, this, remember the xy plane, and that's the uv plane. This is going to go from the u's being 1 to 4. So 1 to 4 on the u's. And the v's are going to go from 2 to 5. So we go 2 to 5. All right, so this should be pretty easy integral. We're going to integrate first over du, so we go u squared over 2 minus vu. And we'll go ahead and go from 1 to 4 on that. So we go 16 divided by 2 is going to be 8 minus 4v minus 1/2 minus v. Okay, so that'll give us like 15 over 2 plus, minus 3v. And then we'll integrate that from 2 to 5 over dv, not forgetting the 4/9. And, well, kind of running out of a little bit of room here, but you can do this one on the next line here. We'll basically say that 15 over 2 v minus 3v squared over 2, sending that the 4/9 over there from 2 to 5. And plug this into the calculator, we'll get 15 times 5 divided by 2 gives us like 75 over 2. And then we're going to have a 5 in there, so 25 times 3 divided by 2 gives us 75 over 2. So the inside is, the first one is actually 0. And then we're going to subtract. If we plug in the 2's over there, we'll get 30 over 2, which is 15, minus 4, 12, that'll be like a 6. And then we're going to have 4/9 right there. We're almost done. If we just solve this, this could be a 0. This is 15 minus 6. It's technically going to be a minus 9 here. And then you have a 4/9 there. So these will cancel. You'll get negative 4. This is the final answer. Oh my God.